Hello, good morning and afternoon to everybody out there. This is Jim White, EdgeX TSC here. Thanks to my fellow EdgeX community members for attending, and welcome to all of our guests. They're just dropping in here today's talk. One announcement to the EdgeX TSC, there will be no TSC call tomorrow, but there is a monthly architects meeting later today at 1 p.m. So we are absolutely delighted to kind of kick off a series here today of talks under the Vertical Solution Work Group over the course of the summer. This series will highlight organizations that may not yet be a part of our community, I'll emphasize the word yet, but are using EdgeX in some form in the field as part of their Edge IoT solutions. So our hope is to allow all of you to learn why EdgeX works for them. What works well, what should we keep doing, what are some of the things we need to consider and improve on, and add as we go forward. We enjoy a lot of success right now with 6 million container downloads. Great achievement, but with an eye to the future, we look to hear straight from the field, and we hope to learn a great deal about EdgeX and how it is positioned for that future. So we are really grateful today to have with us our guest, Allan Houghton. Allan is been with Accenture for almost 9 years. He is currently a senior manager and a global lead working in Accenture to create an advanced Edge Analytics Gateway as part of the AIP Plus initiative in Accenture. AIP Plus is Accenture's collection of modular pre-integrated AI services and capabilities designed to make it significantly easier to adopt AI throughout your business and scale new solutions faster than ever before. Allan lives in Rochester, UK. I'd ask our audience to please go on mute during Allan's talk, and without further ado, Allan, welcome.
Thank you, Jim. So hopefully you can see my slides. Thank you for the good introduction. So, okay. As Jim said, I work for Accenture as part of the Accenture Applied Intelligence Platform, AIP Plus, and I'm based in London. I'm actually the global lead for IoT Gateway development, and I'm also heavily involved with IoT security. I'm ex-Symbian, which was acquired by Nokia, and then Nokia was the Symbian Nokia team was acquired by Accenture. So I made my way into Accenture through unconventional path. But within Accenture, I've been working on IoT solutions for probably 7 of these 9 years. Although when I started working on IoT, it wasn't actually known as IoT. So I don't know how much of you know about Accenture, but to give some background, Accenture is a global consultancy with over 500,000 employees. I think it's around about 513,000. That's certainly the last number that I've got. As you can see, the AIP Plus part of Accenture covers a wide range of industrial sectors. I'm not going to drain this slide at all because there's much more interesting things to talk about. But this is to give you an idea of the type of technologies that we work with, aerospace and defense through to consumer goods and services. I've worked on some connected home solutions. I've worked on oil and gas solutions. We've worked on resources. I've even worked on a connected stadium solution. Accenture, with a wide range of different clients, it's a really interesting place to work, and I can honestly say that I learn every day, and we work on some fascinating projects. So let me take you through AIP Plus. This is an abstract. It shows that AIP Plus is a cloud platform. It's a cloud platform that's designed to be cloud platform agnostic, if that makes sense. And that we provide services that run on top of AWS, Azure, or Google. And we provide a range of capabilities for extracting what we call actionable data and insights from collected data, also known as big data. So our big data processing capabilities is made up of a number of pre-packaged industry solutions that solve the most common problems, but allows consumers to run their own business logic and create their own solutions on top of AIP Plus. So there's a very active developer portal. The idea is that Accenture engineers or our clients can use a range of tools, such as a data science workbench and our model manager to create analytics models, analytics pipelines. And we've got a low-code, no-code approach to this. So there's a model catalog that people can use to select model steps, analytic steps, basic rules, transformations, and link them together into pipelines. With rules that can either apply business logic or machine interaction at the edge. There's also a tailored experience builder layer that allows to give very personal insights, very personal data for, say, consumers or enterprises. So whereabouts does the edge fit in? Let's introduce it. So The Edge is designed to be an extension of the AIP Plus cloud platform. It's very important that you realize it's an extension. It's designed to enhance and extend AIP analytics processing capability. And the idea is we have the Edge, which deals with information that comes very close from the IoT devices, data flows, control flows that it interacts with. So we have the capability to do real-time local analytics and provide real-time actionable insights within the context of the IoT arena that an Edge is working in. But at the same time, the Edge Gateway interacts with the AIP Cloud to provide the usual type of big data insights that I think most of you will be familiar with, from service management, resource management, enhanced planning, data modeling, and even things such as digital twin. So if you think about it, it's in two steps, two stages. There's the AIP Edge, which is real-time, and AIP Cloud, which is big data analytics, non-real-time. So here's the marketer slide, much prettier than my slide, as you can see. But basically, it captures succinctly what I've just said. AIP Plus Edge augments existing AIP models by operating as part of an analytics processing pipeline and provides the ability to interact with IoT devices and to filter, aggregate, and generate relevant insights that can be sent to the cloud for further processing or given to something like a factory floor manager so that they can keep on top of whether their estimated production targets are actually going to be achieved. Because of the very nature of the IoT, the AIP Plus Edge has to be capable of interacting with a large number of IoT devices and IoT protocols and be able to run semi-autonomously, quasi-autonomously from independently from the cloud in areas where there could be intermittent cloud connectivity or low bandwidth. So it's not always possible to have a fat data pipe connecting your edge to the cloud. There are real operational constraints that we work in, and I can take you through some of the battle scars that I've achieved over the past 7 years. So, okay, what we're looking at is, broadly speaking, three classes of use cases that make sense at the edge. We have what you'll all be familiar with is the time-sensitive use cases, where data loses its value after maybe some milliseconds, maybe some seconds, maybe some minutes. But the value of data decays with time. And by being able to process that data at the edge, we can add value, we can use the data whilst it's fresh, and we can introduce some new use cases that can make use of fresh data. And as you can see, there are things here such as production line monitoring, safety monitoring, production availability and optimization, quality control. Then we get into high data volumes. If there's a one of the big problems with the conventional IoT model, big data model, of having a cloud-centric analytics platform is it used to work very well, and arguably still does work well, but there are limitations that are being realized now, in that sending everything to the cloud is fine, but with more and more connected devices, with more and more information flows available, with more and more IoT information sources, sending everything to the cloud has a couple of constraints. First of all, your cloud starts inflating like a balloon, so you have storage costs and you have processing costs. But you also have not inconsiderable backhaul costs, the cost of getting information from the IoT to the cloud in the first place. There are various ways of getting around this, such as collecting your IoT data in batch files and loading the batch files offline into the cloud. But if you want any semblance of real-time response or rapid response, then you have to have your devices connected to the cloud. So by running an Edge Gateway with that can process a high data volume, you can add value. You can start filtering data. You can start aggregating data. You can start doing mathematics or analytics predictions on data and pass the results of that to the cloud, reducing the amount of data that goes to the cloud. Therefore, you reduce the onus on cloud storage, you reduce the backhaul cost. And that allows you to do conventional things where you have a lot of data to be collected. Your preventative, predictive, and prescriptive maintenance mechanisms become easier to implement, and within the context of the IoT domain that you've been deployed in. There's the concept of digital twin. You can collect information that's relevant and send it to the cloud, but you can also build a detailed model at the edge. And there are also things such as retail analytics that we've been looking at. And I mentioned Smart Stadium. That was one of the best jobs that I had in Accenture. I can't tell you who the client was, but it involved a tour of the stadium and some very famous footballers. But the third use case context that we're looking at is context-sensitive information, which is where your information is of most value when it's applied locally, when insights are applied locally. And that could be in, say, a shopping mall, smart buildings, stadiums, generating in-store demographics, doing things such as consumer fraud detection. But one of the benefits of a Venn diagram, apart from being the only diagram I can draw, is the ability to show where your sweet spot for use cases is. And we're focusing very much on video analytics and robotics at the moment, with some thought going into security analytics, real-time security analytics for industrial networks. So our sweet spots at the moment are a lot of video analytics use cases and robotics, and using analytics to interact with automated production lines. So hopefully that's given you an insight into the type of things that we're doing in Accenture with an AIP Plus platform and an edge. But why did we choose EdgeX Foundry? Well, the reality is that generating an IoT solution, making money from an IoT solution, monitoring and maintaining an IoT solution is really hard. It's really, really hard. There are the things that you'll be very familiar with. The IoT solution landscape is incredibly fragmented. There's numerous options for your cloud platform. There's a wide variety of IoT device manufacturers, both gateways, sensors, actuators, etc. There's an amazing variety of IoT protocols, some of which are proprietary, some of which are standards-based, and some of which are standards-based but missing features, missing functionality to keep costs down. Lots of OS choices, lots of chip architectures, many different competing frameworks, and varying degrees of device intelligence, from the extremely dumb through to the very smart. But that's not all. Those aren't the only problems with creating an IoT solution. IoT solutions have to be long-lived. Very often we're dealing with, say, industrial infrastructures, or even in the consumer arena. The devices that are deployed are expected to have a lifetime, certainly in industry, of 15 to 20 years. And that basically means you have to consider the obsolescence factor. If you consider industrial solutions with, say, consumer high-tech, we're used to replacing devices every couple of years. In an industrial scenario, that just doesn't make sense. So long design lives are a hindrance. Not only from a practical perspective, from an operational perspective, but also from a security perspective. There are other factors that need to be fitted in, such as your IoT solution is expected to be autonomous and have incredibly high availability. And that goes for all IoT solutions, consumer and industrial. People get very annoyed in the consumer space if their solutions aren't working. You think about when your Netflix goes down, or Amazon Prime. But in an industrial scenario, there are many safety, regulatory, service level agreement problems that get caused by non-availability. So reliability is essential, but reliability with autonomous devices means you don't have a guy there that can push a button and reset something. So it really is the high nines for reliability when looking at solutions. Because we don't have a guy on site, because getting a guy on site is expensive, we need the ability for secure remote access to deployed solutions so that we can monitor the health of solutions, detect trends that might indicate that the problem is emerging, be able to fix things, be able to gather basic operational statistics, and be able to change parameters if we think there's a problem or if we think there's some adaptations that's needed. But that remote access has to be secure, because trust me, if people know that you can get into a device remotely, then the bad guys are going to give that a damn good try. I mentioned the high availability is a problem. Another reason it's a problem is an obvious reason, but it's not obvious unless you're told it's obvious. It's applying patches can often cause devices to reset. Resetting a device in an industrial situation could cause an outage, could cause a safety implication, and often applying patches is not the work of a moment. It can take weeks or months to actually apply patches in a safe manner and to know that they've been applied. And to cap it all, faults in an IoT network are incredibly difficult to diagnose and fix. And I'll get onto these reasons later. But so what I liked about EdgeX Foundry, why I decided that this was a platform that we wanted to use for our Edge gateways is it's hardware and OS agnostic, which is good, and there are lots of options for cloud connectivity, which allows us to continue to operate, interact with our current chosen cloud platform suppliers. But for me, the real clinchers were the rich variety of IoT protocol connectors. That gives us greater use case customers coverage and potentially more customer access. The microservice architecture made it very easy for us to replace some components with Accenture AIP and tailor the gateway to be an AIP Plus extension rather than an EdgeX Foundry gateway that just happens to be able to interact with an AIP Plus cloud. And the ability to download Dockerized containers meant that to an extent we can be technology independent with the type of models that we run on the gateway, which means we have more operational choices that we can use and more standardization that we can apply. So basically, in short, EdgeX Foundry allows Accenture to concentrate on the value add, which is the AIP Plus extension, the analytics models that we run at the edge, and not worry about the underlying connectivity or the portability to different platforms. It allows me to stop inventing the wheel every time we have to port onto a new device because a customer wants Windows 10 as opposed to Linux. So there's an awful lot of positives that appeal to me about EdgeX Foundry. What have we done? Well, this you will be familiar with, so I won't train this at all, but this is my stylized representation of what we've done. And basically, we've done some modifications to the top level. But first of all, I show the Edge Gateway and other supporting Accenture components. It's important to realize this. We have the AIP Plus cloud components at the top here in this rectangle. These are the software mechanisms in the cloud that support an AIP Plus gateway development and deployment. So we have Model Manager and Agent Builder that I mentioned. We have the device inventory that shows the devices that we can download onto and monitor, or the Software Manager, which maintains configuration control of the actual software that's deployed. And we have our portal for gathering device configurations, telemetry, sensor information, and IoT information flows. And this has been tailored with the EdgeX export services. So we have an AIP Plus specific export that interacts with the conventional AIP Plus device management mechanisms. And we've introduced our own model execution mechanism that means that models that will run in the cloud can be deployed and executed at the edge. So an AIP Plus model engineer doesn't have to worry about the execution environment of the models. They know that if they can build something and execute it in the cloud and it's formatted for the edge, it will run on the edge. So this was very important for us. Obviously, the edge models are tailored for the use cases that I identified earlier, the real-time efficiency, the CPU optimization, memory optimization, being able to filter information, etc. But in principle, if you want to develop a model for the edge, you should be able to build it and test it using the cloud tools and then deploy it to the edge. We've also introduced a couple of interesting components down here. Let's get on to on the next slide, because this, in a nutshell, is what we've done. We've implemented a mechanism called the Edge Orchestrator, which allows us to sequence models, rules, data transformations, and also to split processing between conventional GPU, CPU execution rather, and GPUs if we have hardware acceleration there. The SMA has been tailored to interact with the Accenture components at the lower level and to initialize and configure the Edge Orchestrator and the basic model setup. Down below, we have two interesting additions that we've been talking to IoTech about. The Chronicle is a low footprint, high speed time series database built into the device services layer so that it executes as a basically as a device driver. It is not subject to the jitter that anything running at the microservice layers above it would suffer from. Basically, it ingests data in real time. And we have this guy here that's one of my favorites. This is my device data simulator, which it's not an IoT protocol simulator, it's a data simulator. And it allows us to simulate IoT device interactions by presenting the data that would be received across one of these IoT protocols into the higher layers. So it gives us a lot of advantages with test automation because by downloading a new test file, we can test a different model. So we can have multiple models configured, run, and tested using different test files injected by the data simulator without having to reconfigure an IoT network. It also allows us to give nice demonstrations without having somebody say, apply a hairdresser to a temperature sensor to show that, hairdryer to a temperature sensor to show that temperatures are increasing. And we can capture data from the field and capture it in a file and play it back in one of the Accenture labs so that we can debug information, debug scenarios that may be faulty or exhibiting strange characteristics in an Accenture lab without, again, having to get a guy on site with a whole bunch of test equipment. So it's a nice extension to the device services layer. It's important to realize, and we'll get onto this in a second, that AIP Plus is part of a completely integrated solution of tools in the cloud that support the creation, the deployment, the monitoring of AIP Plus gateways, down to the fact that we have a commissioning app. I missed that out on the previous slide, but the commissioning app is, at the moment, it's an Android-based mobile device that runs AIP Plus commissioning software that allows a field engineer to make sure that all the devices that are installed in a local IoT network are connected to the gateway in the right manner. All the data flows are connected to the correct model connectors, and to run tests on site to prove that that connectivity is working. This is really important because, especially with third-party installers, you get a lot of devices that are installed in the wrong location or even with the wrong orientation. One of the projects I worked on last year had it was a connected home solution with the ability for the homeowner to have solar panels that could generate electricity and put that electricity into the grid when they weren't consuming it. So obviously the meter for the solar panels had to be installed the correct way around so that you could see positive or negative electricity flow into the home. We had a few examples of the installer installing these basically upside down, and we couldn't work out for a while why we were getting incorrect readings or inconsistent readings. So the commissioning app is a really useful add-on based upon Accenture's years of experience of fighting with IoT networks. So what I insisted upon was going to market with a commercially supported set of IoT protocols. We're very lucky to have met IoTech incredibly early on in the development. And we've worked closely with IoTech for probably about 18 months now, maybe a bit longer than that. And we've picked up IoTech's Edge Expert implementation of EdgeX Foundry. The the big benefit of this is that Accenture don't have to worry about the underlying EdgeX framework infrastructure. We just worry about the areas that we've changed and that are adding Accenture IP and Accenture value to the solution. And it also means that IoTech support us with the IoT protocols that they have certified. So it means that I, as an engineer, don't have to worry about getting IoT data generators, test sets, etc., to prove that our implementation of the IoT protocols is correct and standards compliant. So we've been working incredibly closely with IoTech on this solution, and I think it's been beneficial to both parties, but we can let IoTech comment on that during questions and answers. So where would I like EdgeX to head? I love it. I think it's great, and we're investing significant amounts of money in ensuring that EdgeX is a valuable component to extend AIP analytics capabilities. It would be really good to collaborate on some of the other issues that we see. But based on my experience of IoT deployments, they're very, very difficult. So having some standardized tooling to support the IoT devices that have been deployed to monitor the configuration, to help with administration, to be able to support other intelligent IoT devices that are connected, so that we can have semi-autonomous devices connected to a gateway as well, being able to stage the deployment of software to them. Also, maybe having a set of recommended frameworks that we can standardize for creating things such as video analytics or robotics frameworks, and having certification schemes for supported or recommended devices, so that we can say these devices are guaranteed to work with EdgeX. Another thing is, a lot of the use cases I mentioned, they make use of, they need deterministic responses. So we're doing an evaluation at the moment with IoTech on the XRT implementation. But I think the biggest issue I have with IoT solutions is not so much the gateway side of things. It's where the IoT devices actually live. It's the IoT network itself. And I can touch on some of the issues why I think having tools that help us diagnose faults on the IoT sides is good. I've worked on projects where we have IoT network congestion. It's usually been on mesh networks that have been incorrectly configured, but we can get network congestion causing information to be lost. Not such a big issue if you're expecting information at a regular interval. You can detect that you've lost information and request it, but it does become a big issue if you've got battery-powered devices that will wake up, send some data, and then go back to sleep. If you lose the information from a battery-powered device, you've got no way of waking that device up remotely, so it's gone. Also, IoT network interference can cause data to be lost or corrupted, and that can be electromagnetic interference. So you might be looking at something like an ISA 100.11a with some frequency hopping capability in it to get around network interference. IoT device failure is another one. IoT device failure can cause bad data to be sent or no data to be sent. I mentioned IoT device misconfiguration. So incorrect installations by third parties can be a major issue. And of course, there's the end user interference as well. People unwittingly switch off IoT devices. They can, well, one situation, they actually pull the plug out from a router. And caused a whole bunch of information to be lost. Took us a while to debug that. But IoT devices can be switched off, they can be moved, they can be damaged by inexperienced employees of our clients. And of course, there's also the third-party device fault, which has been probably the biggest pain, where the devices that are connected to your gateway have some sort of logic fault in them, or some sort of incorrect IoT protocol implementation, which means that they don't always work in the manner that you expect them to work. So being able to have a standardized set of tools that allows us to monitor the state and health of IoT deployments is something that Accenture is working on. But it'd be really good to see what ideas there are from the community and see if there are things that we can work together on, potentially generate together and standardize on. So that's just about on time, which is unusual for me. That's a high-speed tour of AIP Plus and the Edge Next. And hopefully it was coherent, but feel free to ask any questions.
Allan, that's great. Really appreciate it. And we've got a ton of questions that are coming in over chat, but I know some other folks also have some questions here. So I'll kick it off with one of the questions that's on the chat line, and then that'll allow people hopefully to warm up here and get your mics ready. But one of the questions that first came in from David Martin was what about privacy with respect to content-sensitive components? Is that a concern, and how are you addressing that?
Actually, I was having this discussion with one of our architects earlier. The edges, the implementation that we have actually has some privacy advantages. Take, for example, a connected home. You can gather information within the context of the home and never have to send it to the cloud. Potentially, you could use, say, face recognition to recognize household members and set device settings or room settings, whatever, to their preferred settings based upon the identity of the individual. That wouldn't be possible if we sent the identity to the cloud, but because it's kept within the context of the home, and it's the actual home users, the people that are able to configure these devices, they're actually giving the device the permission to capture their images and process them, then that's one thing, one set of use cases we haven't implemented, but potentially we could implement if we chose to. Obviously, if we sent that information to the cloud, then there's a whole bunch of privacy implications that we would have to take care of. The other thing, which is actually much more practical and realistic, is because we only send relevant information, important information to the cloud, we can discard a lot of information at the edge and package it up in a manner that's either anonymized, or if identities have to be known for, say, billing reasons, then we can pseudonymize the information. But we can do that actually at the cloud, at the edge, and then we use the conventional TLS 1.2 encoding to encrypt it to the cloud. So we have information anonymized at the edge or pseudonymized at the edge, sent to the cloud, encrypted and stored encrypted. So it's there are a lot of advantages of running an edge type model, but hopefully that gave an answer.
Thanks, Allan. Do we have other questions from those who are online? And please unmute yourself, folks. I had to mute everybody's microphone, so make sure you unmute and just speak up. If not, let me go to another question from on the text chat. Jim St. Ledger, who is our LF Edge TAC chair. Welcome, Jim. He asks, is EdgeX the only framework Accenture uses and supports? If not, how do they position EdgeX versus the other options to customers? What other options were considered? What are the advantages of those options? And what would they like to see EdgeX add next to a key feature or capability?
So there are other gateway implementations that we've got, but one of the issues that we've had is we've found it very difficult not to reinvent the wheel with different project teams, different client implementations. So we used to use Cura, and in fact, in our older deployments, we still use Cura as the basic structure for the gateway implementation. But with EdgeX, with it being so portable and agnostic against the hardware, chip architectures, multiple protocols supported, etc., it gives us a really nice framework for going forward. So we no longer have to reinvent the wheel for each client deployment. The EdgeX is used within AIP Plus, but it's not used throughout Accenture. It's our mission to make it the de facto standard throughout Accenture and the AIP Plus as the cloud platform. But we're probably a few years away from achieving that. The Edge itself, I think the features that I would like to see in the Edge, hopefully I gave you an insight into in the last slide that I presented, but the type of features that would be really useful from an Accenture perspective, that they are largely based upon the pain that I've had from IoT deployments. That slide is really my take on things, I wouldn't like to say it was sanctioned by Accenture and everybody in Accenture thought that. It's only because I'm the dev lead on EdgeX Foundry that I mentioned these things. But that's through bitter, hard-won personal experiences.
Thanks, Allan. Do we have other questions online?
Yes, this is Camilo. Hi, Jim. Hi, Allan. Thank you for the presentation.
Hi.
So when you look at across different verticals, how much would you say is consistent from what you described? I know this is mostly horizontal, but if you will assign a percentage of how much you can carry forward being vertical agnostic, what would that be?
That's a good question, actually, because I've been focusing largely on industrial use cases. So the industrial use cases that we have, I think we're largely use case agnostic because I liken this image to like Thunderbirds. If you've ever seen the 1960s, 70s TV show Thunderbirds, where there's a plane, Thunderbird 2, that you could drop different pods into and it would change the profile of a mission. I liken the Docker capability of being able to change the personality of an edge gateway. So although we've been focusing on industrial solutions, in principle, we could move into retail. We could move into connected insurance. We've actually been trialing some video analytics for a smart city, where it's actually part of smart city hazard recognition capability, where we recognize potholes by attaching cameras to garbage trucks that go along go into every street in the city. So I think the vertical use cases, the EdgeX capability gives us a generic software platform that should allow us to run Accenture Analytics for any of the vertical use cases. The constraint would be how expensive the gateway has to be. So in an industrial setting, clients, they want high availability, high reliability, high safety, and I'm prepared to spend more to have a more capable, more expensive gateway device that maybe would be possible in a store. So the limiting factor for the vertical use cases, for the different industry use cases, would be the type of devices that we're running at the edge, and therefore the amount of processing power and memory that they had for the models that we're applying. But in principle, as technology evolves over the years, if you apply Moore's law, as we always did in Nokia, then in a couple of years, things that are barely possible just now on low-end devices become more and more possible. So I guess the sky's the limit, only really impacted by the cost and capability of the device that you're running your analytics on at the edge. The intention is we have a standardized edge framework that can run any industry vertical.
Another question that's come in from the chat window, Allan, referring to AIP plus Edge Agent, do you use hardware accelerators at the edge to run the different analytics models, or is it done
Yes, we do.
in the AIP cloud?
We use hardware acceleration. We're doing a lot with video analytics at the moment. So some of the devices we use, we configure GPU execution and CPU execution running in parallel. So we can spread models, model components, model steps, so that we can use video acceleration, GPU acceleration, and run conventional parts of the model on the CPU. So yes, we do.
A question I have for you, Allan, too, is you were talking about your changes to EdgeX, and you'd made some adjustments to things like SMA. If you look at metrics collection, is there a point at which metrics collection is meaningful and a point at which it's too much information? In other words, are you looking for metrics coming out of EdgeX to kind of be minimal, that things are up and running? Or do you want some deep-seated information? You know, how many messages, what devices are saying and doing? Can you give us some indication of where you kind of find the needle in terms of metrics collection?
That's a really good question, because one of the bugbears is engineers often put in too much debug, too much diagnostic information, and then they wonder where all the performance has gone. So what we're implementing, what we have not implemented yet, but what we're implementing is a tunable metrics collection capability. So we have a default set of metrics which gives us the overall health of a gateway. So we know it's up and running, we know the identity of the devices that are connected, we know whether we've lost a device or whether there's a new device connecting, and we can gather some limited information about the health of the communications from the devices through the device services there. What we do is we at the moment we've got a Grafana interface in the cloud, and we run some pre-processing on the information from there. So we give a visual representation of the health of the deployed devices. And if a device is showing that not everything is healthy on it, or there's a trend which could indicate a fault, the operator is notified, and then they have the ability to connect to the gateway and request some additional information. So we don't send up all the information all the time, but if necessary, then the operator can command additional information to be sent. But of course, that potentially has an impact on the gateway performance if it's a low-end device. So we want that to be under operator control, administrator control, and to be done when necessary rather than done all the time.
Thanks, Allan. A couple of questions. I'm bouncing between a number of people who are sending some things in here. I know David Martin is asking about high availability for the gateway. Do you see K8, K3 needed for a gateway? NVIDIA, Intel, Google, any favorites?
I could only give my own answers there.
A loaded question, it sounds.
Yeah. I'll duck that one at the moment. I think I'd probably get in trouble with my product managers if I answered that one. But I think it would be fair to say that we're playing on all devices. We're making use of NVIDIA. We've got Google TPUs running. I mentioned we're capable of interacting with Google Cloud. We're actually looking at some alternative to the basic SMA implementation as well. So yeah, I'll steer away from the details of that question and be woolly on that one.
Thanks, Allan. Jim St. Ledger asked another question. He says, have you looked into SDO, one of the LF Edge projects for secure device onboarding? Also, have you looked at video analytics solutions like OpenVINO per one of your requests?
For the first one, no, but I should do. Obviously, security is of paramount importance. We've been operating to our AIP Plus security model, but I know also been talking to Keith about some potential enhancements there, and we've got some discussions taking place next week. But I should really have a look at what the foundation is doing. And yes, we've got models that run using OpenVINO at the moment. So we've got a whole bunch of different implementations, and OpenVINO is one. It's actually a good technology collaboration that we had with IoTech, where they were explaining some of the video use cases that they'd been looking at, and we moved away from our basic TensorFlow variations and had a look at OpenVINO, and it is a good framework as well. Yes, so we're one of the beauties of Accenture is we're not hung up on any particular implementation. What we look at is something that's going to be cost effective and provide the functionality that we need, and OpenVINO is one of the solutions. Yeah.
Probably have time for maybe a couple more questions. Folks online, do we have somebody who has a question online?
Yes, I have a question.
Go ahead.
Yes, this is Daniel Akawi from RF Rain. Really enjoyed your presentation. One of the points I'd like to ask you is the EdgeX Gateway, in my opinion, can do but so much if it has to interface with a lot of devices. So one of the keys to really simplify the IoT integration is to make the end devices much smarter than what they are now.
Exactly.
You did have, very low level protocol. I did work on CAN actually for a year and a half for a while. That alone is a lot, takes a lot of resources to even master. In other words, having all that intelligence in the EdgeX actually gateway is going to have different type of results. I'd like to see your take on how to encourage companies to have more and more smarter devices on the edge, and discuss a bit about the protocols that you can have. For example, the REST API protocol, where all the complexity is done on the edge, and then the Edge Gateway, EdgeX Gateway, can take all that information and then process that data appropriately.
That's a good question. I alluded to that in my list of things that we should consider going forwards. And it is exactly that. It's the use of more intelligent, more semi-autonomous devices within networks, because where we would like to head is to have much more distributed analytics models and processing models. So we can have intelligent devices that the gateway can configure and communicate with, but a lot of the smarts is taking place on those devices. And the actual communication between the device and the gateway is, say, start, stop, give me your important data. So you're absolutely spot on with that. We don't want to have all the analytics processing, all the data processing taking place on the gateway, because in effect that just moves the data processing problem from the cloud to the gateway itself. The gateway then becomes a bottleneck. So
I'd love to discuss with you after this call.
Well, actually, I think you'll have my email details.
Fantastic.
Good.
Thanks, Danny. Other questions from online?
It's Keith here.
I have a question.
Sorry. I was just going to ask, I think Camilo, we were going to ask if Allan would be prepared to do some kind of blog, right? Or what you got some idea about, penning this to paper? Is that, I can't remember the exact thing you were going to ask him.
Yeah, it would be great if we can have a case study around what your experience was as Accenture, basically what you went through today. So that would be a great next step. So it would be great if you can help us with that, Allan.
Oh, post-traumatic stress disorder, going through that. So it's been, I've gained my experience painfully. I think that's one of the challenges, one of the interesting things about the IoT that really has me so enthusiastic about it, is that we're limited by our imagination. And we're only limited by our imagination. But I think from experience, if anything can go wrong, it will go wrong. And I mentioned some of the things about third-party installers fitting devices upside down. Even silly little things like having identical sensors. And you might have one for interior temperature, one for exterior temperature. And getting these devices swapped around, that plays havoc with your model. But yeah, let me consider that. I'd probably have to go through our product management route to okay that.
Absolutely.
But yeah, it's something I'd be open to.
Excellent. Thank you, Allan.
There was a gentleman who spoke up just when Keith came up. Do you want to ask your question?
Yeah, this is Jack. Actually, I have a question because I thank for Allan's introduction. This looks a very nice and beautiful architecture, and gives you flexibility and security advantage where you provide solution to your end customer. So my question is, when you're talking to your end customer, end user, for example, in retail or industrial, what is the value they mostly, what is top 3 they most value thing about your architecture, or they just look at it as a black box or something?
To be honest, the majority of people look at it as a black box. It's a means to an end. It's a tool. I think it's the Accenture solution creation teams that value this more than the clients. The clients, to be honest, they're more interested in what the overall solution can do to provide them insights that will either save them money, make them more regulatory compliant, increase safety, improve quality, etc. So these are the things that the client values. What they want as an implementation is something that's cost effective and reliable. And that's where the EdgeX Foundry, the AIP Plus combination comes in very nicely, because we believe we can address a number of different client use cases with a scalable platform and different cost gateways based upon the solution. So to be honest, the clients are not really interested in the underlying technology. They just want to know that it works and it's going to make them the money or give them the cost savings that are required.
Jim, can we ask more questions or?
Go right ahead.
Yeah, thank you. Allan, thank you so much for the presentations. Two questions on your business, on your models that you have. Do you in a way separate the data from the application and store the data in some kind of common repository so that the applications can infer when inferring, the needed resources, and you can apply these applications across different use cases? And the second is when it comes to the connectivity, in addition to the cellular connectivity, do you also provide wireless to Wi-Fi generation 6 as well as on the Ethernet on single pair Internet? Okay.
So to take the first one.
Thank you.
It depends upon the use case to be exact. We have the capability of storing information on the edge, either through the Redis database or through the Chronicle time series database. So we can gather information and process it, looking for anomalies or patterns that could indicate particular business value attributes that we're looking for, or indicate faults. So, but we don't do that in our use cases. For example, with processing video analytics, we take the data streams, we make the inferences, we perform the actions, unless it's a safety related issue where we need to take a snapshot of whatever's happened. That video is basically gone. We're providing an autonomous service, so we're not storing the video. In fact, to store information, say video streams, would take a lot of storage capacity at the edge. So yes, we do have the capability of doing it, but it's dependent upon the actual use case. The majority of post-processing would be done in the cloud itself. So we would pass information that's relevant for the use cases and for post-processing to the cloud, where the conventional big data analytics engines would be able to munch that further. The advantage of the edge is we don't send all the information to the cloud, we send relevant information. So if a data value doesn't change, we don't bother sending that. We'll send it when it starts to change. So we cut down the unnecessary chatter, the unnecessary backhaul costs by reducing the amount of bandwidth that's required. Various connectivity options. It depends. It depends again on the use case. I don't think we've got any satellite deployments at the moment, but potentially we could have low bandwidth streamed to satellite and then bounced into an AIP Plus cloud implementation. I don't think we do that, but that would give an additional emphasis for having the gateway running autonomously. And only sending low bandwidth comms when required. But there are a number of comms options. Yeah, SIM options, having the gateway connecting. Well, in fact, one of the use cases I think you might have seen on my Venn diagram was being integrated into a 5G base station, so we could provide context-sensitive information. This is based upon the connected stadium work that I was involved in a couple of years ago, where the football club that we were dealing with wanted to have the ability to provide access to the football club's store. So people could buy things online, order drinks, refreshments online, and see things that the usual football fan is interested in, such as other team scores in the league, bus timetables, etc. So we were going to provide a local server that cached a lot of the information that the stadium occupants would have without always accessing the internet itself. The reason for that is round about football stations, if you have a telephone mast, connectivity works fine for most of the time, except when you suddenly get 100,000 people in the stadium, then that just swamps that particular cellular tower. So we wanted to do some context sensitive information, cache useful information within the stadium, and reduce the amount of access to the internet using basically building ourselves into a 5G base station. Did that help answer your question?
Well, thank you, Allan. Well, yeah, yeah, thank you, thank you.
Everyone, thanks so much, and in particular, Allan, on behalf of the entire community, thanks so much for the talk and the time you shared today, sharing the Accenture story. It was fantastic. Hey, Keith, thanks also for your recruiting and extending the invitation to Allan, to May, Henry, Camilo, and Andy. Thanks for all the efforts in getting this set up and handling all the marketing efforts in relatively short notice. We had about 75 attendees online today, so well done, everybody. For those in attendance, we have Thundersoft presenting in a few weeks. Look for an announcement there. And then we have Zhengjing Intelligence presenting at the end of the month, that is end of July. The recording for this talk will be made available today on the EdgeX Wiki. In fact, Henry's already done us all a favor and presented the link to the wiki out there in the chat window. So go out and click on that. We'll have the talk and the recording, and also we've captured the questions from the chat. We'll try to have those out there with some answers as best we can, as soon as we can as well. But again, Allan, thanks so much. We really do appreciate it. Thanks for everybody for attending. Allan, any last comments?
No, it's been a pleasure. I think EdgeX Foundry and the possibilities it opens up are amazing. I've been a massive fan of IoT technology for years. I just find it interesting. I said we're limited by our intelligence, not intelligence, our imaginations and our intelligence, I guess. It's a fascinating area, one where there's continuous innovation and development, and that's what keeps me going. It gives me the enthusiasm to carry on.
Great. With that, everybody, thank you much. We'll talk to you all soon.
Cheers.
Thank you.